Okay, so here we go. The first example problem. So it's something we've talked about before. It's basically give you a matrix and ask you please verify the rank equation for this matrix. So the way we know the rank equation is actually the number of column equals to the rank of this matrix plus the nullity of this matrix. Alright, and the way we're going to find rank and nullity of this matrix is to reduce this matrix into REF and find a null space and column space respectively and find their dimension. So the way we're going to do this is as follows. So first we want to reduce this matrix into REF. Okay, so after several steps of row operation, you're going to find this matrix becomes this REF format. So as we can see, now this matrix is already reducing to REF. So we can check the position of their pivot to see what's the column space and then tell what's the rank. So we can see the pivot is in the first and second column. So according to this, we will know the column space of A is actually the span of the first two columns of the initial matrix. So it's span of 1, 2, 1 and 1, 1, 2. All right. And after we find the column space, we know that the rank of A is actually just equals to the dimension of column space. So there's two vectors inside the column space span. So the rank of A is going to be equals to 2. All right. And then the null space. Again, for the null space, we're going to put exactly the same matrix into homogeneous system. So we just write 0, 0, 0 over here. And again, after several row operation, we're going to get into this format. -2 and 0, 0, 0. The idea of the null space is just we're trying to see like what's the solution of this homogeneous system and then check the free variable vectors and then try to get a null space. All right. And then if we want, you can write it as, suppose this is x, y, and z, then you can write it as x plus 3z equal to 0 and y minus 2z equal to 0. And obviously, according to what we have already learned, we know that this linear system has infinite solutions. And here, an easy way of doing that is we can set z as a free variable. So we can set z equals to t, where t is any real number. Okay? And after that, we can know because x equal to -3z, y equal to 2z, or you can write it here, x equal to -3z, y equals to 2z. So we can say x, y, and z equals to t times -3, 2, and 1. Okay. And after this step, we know according to how we find the null space, we will know the null space of A actually equals to the span of -3 to 1. And of course, the nullity of this matrix, which is the dimension of the null space, there's only one vector inside. So we can say the nullity of this matrix equals to 1. So now we know all the things we need to format the rank equation. So we know the rank, we know the nullity. We can check when we can verify actually the number of column equal to rank plus nullity. So number of column equals to rank plus nullity. Obviously here for this matrix it's a 3 by 3 matrix, so there's 3 columns, and we just know the rank equals to 2 and the nullity equals to equals to 1, so 3 equals to 2 plus 1, and we prove this theorem for this matrix.